In place of hyphen, you can take underscore. And the space is not allowed if a variable name consists of two words, space is not allowed in between them. Okay, space is not allowed in between them. And then what else we had? Input output. Yes, C in, C out. We have discussed this also, I think, on that day. Get from, extract. Yeah, we have done this also, right? Yeah, we have seen these diagrams as well on that day. Structure of C++ program. We had, so link section should be, if without class, this is a structure of C++ program without class. Header file, main function, inside main function, variable section, and executable section. Okay. Variable section means you can declare variables. First dash dash is there. Now there you can go with some variable names. Variables can be declared or initialized, followed with the executable section. This is all executable. Means some is equal to a plus b, c out something like this you can put. That is executable section. And this is main function, and this is link section. Okay. But if you add with the class, it is something different. And you can put comments also anywhere. Comments are not considered by compiler, you know that. And two types of comments are there. One is single line comment, also called as C++ comment, and multi-line comment. Multi-line comment can be also called as block comment or C comment, because it is coming all the way from C language. And a single line comment is coming all the way from C++. Yes, and you can write comments anywhere in the program. Comments give readability to a programmer. Okay. We explained about comments just now, I discussed, and then link section is required. Hash stands for preprocessor directive. What does it do? See, the meaning itself is there in that word, preprocessor directive. Processor means your CPU. Your CPU is directed in advance. Pre means in advance. To what? To include so and so header file. So whenever you include this header file, corresponding functions or objects will be included. Like IO stream stands for input output stream. So what are the things associated with that? Like cout, cin, yeah, you can use them. And if you want to use cout, cin, this is mandatory at the top. Okay. And main function. Always main function starts with void in C++. Because C++ compilers are designed in such a way that main function should return some value. If it is not returning any value, you have to put void. Means not returning anything. If you write int main, you have to give return statement at the end, like return 0 you have to give. That is unnecessary. So better you put void in place of int. What else is there? Some program is given. So this is the program to swap, taking a temporary variable. I told x and y should be interchanged using a temporary variable. Whatever value is there in x, it is transferred to temp, and then whatever value is there in y, that is passed to x, so that whatever is there in temp, that is passed to y. We have seen this before, right? That is swapping, interchange. So these things, I think. Okay, so this unit is done successfully. One more time, we have revised. Any doubts, please ask me in this chapter. Okay, and what about these exercises? Can you do this? If any doubts, ask me in that. If you can do, then only you can get some doubts. If you don't do, you cannot get any doubt, right? So you have to keep on practicing these exercises. So you can just hide the answer and you can question yourself. Like if you take this fill in the blank, dash operators are used to test the relation between two values. Relational operators are used. What is a very simple question? C++ provides two dash operators for which only one variable is required. What is that? Two operators. Yeah, for that only one variable is required. Yeah, A++, only one variable is required. Yes, that is true. The process in which one predefined type of expression is converted into another type, that is type conversion, typecasting, is it not? Yeah, you can answer like that. And you can check immediately, right? Underneath the answers are also there. You can check, right? And then, shall I move to 13th? Yeah. Basic concepts of whoops. So what are the basic concepts of whoops? Like paradigms. You can also call them as paradigms. Yeah, those features we have to understand. See, here are the features. Objects. And you know the definition for object. What is an object? Any physical thing. Any physical thing in this universe can be called as an object. Otherwise, in books they write object is an instance of a class. Let me take notepad. You can, if I can briefly write there, you can understand easily. So what is an object? First thing which they have asked. So physical thing. Any physical thing can be called as an object. Otherwise, what is the other definition? Otherwise, you can also call as instance of a class. Instance means one model for a class, one example for a class, something like that. And then what is a class? Class definition. Class is an idea to create an object. Yes. Otherwise, class is a template. That is also correct. No? Or you can call it as model to create an object or replica. And then what else? Polymorphism, inheritance, all these things they might have given. Yes. Data abstraction, encapsulation. Yes. So what is data abstraction? Means hiding of data, is it not? So how do you hide data? Immediately question will come. So data abstraction is nothing but hiding of data. And what do you mean by hiding? Hiding of data means, how do you hide? Using access specifiers. Access specifiers you can hide. So what are those access specifiers? You know, private and then protected. And then the other one is, what is the other one? What are the access specifiers? Huh? Right, public. Yes. Private, protected, and public are the access specifiers. Using them, you can hide the data. Different levels of abstraction you can do using these access specifiers. Private data is most restricted data. Can I call like that? Because the private data is accessible within the same class in which it is declared. To other classes, it is not acceptable. But you can violate that using a friend class or friend function. But I don't know whether you are having that friend class, friend function. I did not remember. Are you having that? It's not there in your syllabus, I think. Yeah, it is not there. It is not there, but still you can violate. Even if you take private, friend classes, friend functions can access private also. And what about protected? Only if inheritance is there, then only protected data can go to the next level. Otherwise, if there is no inheritance, inheritance, parent-child relation. If there is no inheritance, then protected data cannot be passed to the next level. And what about public? Whether inheritance is there or not, no issue. It can go anywhere. Even to the next program also it can go. Yes. These are the access specifiers which support data abstraction. And then encapsulation. What do you mean by encapsulation? Immediately you should get one word. What is that? Wrapping of data. Wrapping of data in the form of data members and member functions. Member functions. Wrapping of data. How do you wrap them? Data members and functions into one unit called as class. Class is the best example for encapsulation. Is it not? For abstraction also, class is the best example. Inside class, you do abstraction, you do encapsulation, all these things you are going to do inside class. For both the things, the example is you do these things inside a class. Next, what is the next thing? Inheritance. What do you mean by inheritance? Creating a new class. Yeah, existing class. Creating is known as inheritance. Creating a new class from an existing class, or otherwise another definition is there: acquisition of base class features. Base class features. What are the features? Features are nothing but members and member functions. That's it. Yes. So you can acquire these features from which class? Base class. Base is nothing but parent class. So acquisition of base class features into derived class. Also called as inheritance. Next, what do you mean by polymorphism? It is there or not? Polymorphism means poly means many. Morphos means forms. Means what? Functions with the same name. With same name exhibiting different behaviors. Right? Functions with not function functions with the same name exhibiting different behaviors. Behavior means what? Coding. Their definition. You write function definition now. That one can be called as behavior. Task, the actual task, work. Otherwise, you can call it as that is implementation, nothing but. Otherwise, you can call it as function definition. So, what do you mean by polymorphism? Functions with the same name but exhibiting different behaviors. But exhibiting names are same, but behaviors are different. And how do you achieve this? You can achieve this by how to achieve this? By function overloading, you can achieve. Otherwise, you can also achieve this through function overriding. So what is function overloading? What is function overriding? In the next chapter, they might have asked, we will check there. So we should know what is polymorphism definition, and then examples for polymorphism are function overloading and function overriding. Yes. Next one. So we have done it all: polymorphism, inheritance, data encapsulation, abstraction, classes, objects. Done. We have done. So class consists of, class will be having some name. See, structure of a class. How class structure looks? Class name you provide at the top, followed with opening brace, and inside class, what will be there? Class variables will be there, class functions will be there. Okay. And after creation of class, at the end, we close the class with a semicolon. Is it not? You can also write structure of a class like this. Structure of a class, you can write like this. I'll show you. You can put it like this. First, you write class name, followed with some class name you write, brace, and then you will declare all the data members, also member functions, and close the class like this, and then go with main function. Inside main function, what is the first job? Create object. Is it not? Create. How do you create object? How do you create? Class name, space, object name. Reference variable. Object name is reference variable. It is generally reference variable object. That's it. That is how you create. After that, invoke the member functions. How do you invoke the member functions? Object dot member function. This is the structure of a class. So class name, and of course header files will be there at the top. Don't miss it. Header file is required anyways. Files like this. Okay. Next one. What is the next one? What is the next thing? Data abstraction. Encapsulation. For encapsulation, you can take example of a car program also. Car also. For outsiders, we don't know. Even driver doesn't know what is there inside car, but he can know driving, how to drive it. Anybody can know, but internal issues are hidden internally, are not exposed to outsiders. Means whichever are required to outsiders, they are only presented. Whichever should not be, I mean, needless to show, they are not being shown to outsiders. Okay, so they are embedded inside that, like engine, even refrigerator, air conditioner. Only we know outside mechanism. Inside machine will be there. I mean, compressor will be there, condenser will be there. We need not know about those things. Okay. Then modularity. What do you mean by modularity? Dividing a program or partitioning a program into small components, individual components, is called modularity. That is what is modularity. So once you make small units called as modules, so the complexity of the program gets reduced because we can easily solve small bits of code. We can easily develop. Okay, and all those small parts put together, you'll get a program, big program, that is so-called application. Just now we have seen polymorphism also we have seen. The same member function in one class, in one function it is showing numbers, in another function it is dealing with strings. Like that you can design addition operation. Okay, they are discussing about addition operation. They have given. See, for example, they are considered addition. Is it polymorphic or not? See, one time addition is exhibiting like addition operator. Add means plus symbol. Plus symbol one time it is behaving as simple addition. The other time it is behaving as concatenation operator. Means joining strings. Concatenate string means A plus B. Strings concatenated like that. str1 plus str2. If you can give, you'll get output like that. And then benefits of OOPS. You can study these things like software complexity can be easily managed. Software complexity means what? Difficulty. If any complex natured things are there, they can be easily managed with OOPS because every object is special. One object is different from another object. So one section of code will develop one object, another section of people will develop another object like that. So many objects we can create very easily, is it not? And then what is the next one? Object oriented systems can be easily upgraded. So for example, if I do a program, after a month or so I can develop one more objects. I can open my programs and I can enhance those programs. I can make them still bigger by adding some other modules or some other uh, objects. So extensibility will become easy. Upgradation will become easily. You can easily upgrade your code. For example, I have not done multiplication or division operator. I have not done in designing a calculator. Later on, I can add that. No issue at all. Okay. And objects can be reused also. Multiple times you can use those objects. Once you create object, you can reuse those objects for multiple purposes. Okay. So objects created for object-oriented program can easily be reused in other programs. So objects can work in other programs also. If you create object in one program, the same object can be used in another program also. If you can use same name, okay. And then programming applications of OOP. So where OOPS concepts are used, they are giving here. Multiple uses of data structure. In data structures, it can be useful. Object-oriented programming and data in multiple programs. Data in multiple programs. If you want to deal, this is an application where the same operations are performed on a data structure in different programs. So their OOPS concepts are useful. Like they have given examples, neural networks, CAD means mechanical students will do that, CAD CAM, object-oriented databases will be there. Okay, these are the areas where it is applicable, object-oriented. So that is about this chapter. Shall I move to the next one, 14th? Total theory, 13th one. Control statements, yes. What are the control statements? First of all, how they have divided compound statement. What do you mean by compound statement? Whenever immediately you should get these symbols into your mind. So compound statement means whatever you give inside braces, curly braces, that can be called as compound statement. Very simple, right? Null statement means if you are ending with a semicolon, generally for loop or while loop, if you end with a semicolon, it can be called as null or empty statement. Okay, generally in loops concept we use that in for loop, while loop. Generally, sometimes we end with for loop. Normally we don't put semicolon, but if you are ending with a semicolon, it means that it is a null statement. Nothing is there in that. Okay. And then conditional statements. Conditional statements means if else, if, nested if, and switch. So what is if statement? What is if else statement? What is if else if? And then what is nested if? What is switch? These are the conditional statements. So we have done before. Simple if, how it works. Simple if. Let us recall how simple if works. If provide some condition. If the condition is true, then you can get inside and execute these lines of code. If false, come out of that. Okay, again you can write another if also if you want, otherwise you can leave it. So if is a keyword, yes. If, for, while, do, all these are keywords also, or you can call them as reserved words. And if the condition is true, then you can put one comment here. If the condition is true, the condition is true, then control transfers to if the condition is true, then control transfers to the function. Is it not? Inside, this is definition portion. If the condition is true, you can execute. If the condition is true, then control transfers to the function. Sorry, it is not function. Sorry, just a minute. You cannot write like this. If the condition is true, then control transfers into the block. It is block. You can call it as block. This is called as block. The condition is true, then control transfers into the block. If false, don't get into the block. You have to get out of that. If false, do not get into the block. That is the difference. After that, if else is also there. How do you write if else? Difference is, what is the difference between if and if else? Same story, you have to write if the condition is true, get into that. Else, go to the else path. If condition is true, get inside. Condition is true. Otherwise, what to do? Execute else block. Execute else block. So we have to write else block for that matter. This is if is false. If the condition is false, don't run this block. Go to else block and blindly execute inside whichever code is given. You can blindly execute that code, isn't it? That is how if else works. And then if they have given here, you can check if else if. See here, if else if else, how it works. If else if, oh, it has gone somewhere. Else if else. First test the condition as usual. If it's true, get inside. You can make a comment saying just like the above one, but little difference. If condition is true, condition is true, to block. Else Test the next condition. Test the next condition. Means you have to go for else if. So how to go into that? I'll give some space. They have given, I think. Let us check. See, if else if some space is there now in between else and if. Here also we need to provide some space. See, like this you have to write. So if the condition is true, no issue, we can execute else space if, again the condition will be there. Here, is it not? If this condition is true, then execute the underneath block. If condition true, else execute which one? Else execute else block. If wrong, I mean to say, if wrong, you have to execute else block. If true, execute this block only. Like this. If that is going to be wrong, then there will be no further testing. Blindly, you can execute the last else block. If the first two conditions are failing, then you can execute else part without any prior testing. Okay, that is how it works. And then nested if they might have given nested if. Nested if and then switch statement. Nested if we understood before also. Let us try one more time. How do you define nested if? Nested is yeah. Like if I will write here. If true, get inside. If I have to provide some conditions, sorry. If condition is true, then get inside and execute. You can execute some code like this, and then again another if will be there. Again test condition. Another condition is given. This may be you can call as condition 2, and here you can call the first one as condition 1. And if this is also true, you can get inside, execute the lines of code inside, and then again you can put some. Again you can go with another if condition here immediately, but you just remember there is no closing. See here, I opened, and inside that another if. This is outer if. You can call this as outer if, whereas this you can call as middle if. And then if it is true, then you can get inside and try for condition 3 as well. It's condition 3. This is inner if. And if this is also true, if all these if conditions are true, means first if outer if got succeeded, it goes control goes to middle if, test for middle if. If it is also true, I mean condition 2 is also true, then go to inner if, and if that is also true, then only you can execute. How many successes should be there to reach inner if? 3 success stories should be there. Condition 1 should be true, condition 2 should be true, then going inside condition 3 should be true, then only you can execute this block. Inner if, when it executes, if all conditions, means if condition 1, condition 2, condition 3 are all true, then you are going to execute this inner if. If inner if is going to fail, what to do? Here we close inner if, is it not? Inner if close it. Inner if. So what to do? Immediately start else. For this inner else, you can call it as inner else. You execute this part. Inner if fails, inner else will be executed. Is it not? So I can make a comment, inner else. This is when it is getting executed. If inner if fails, then else will get executed. Will That's it. Okay. Then if inner if fails, inner else will be executed. Fine. If inner if succeeds, then this block of code will be executed. Okay, right. And if condition 2 is failing, I have to close here this condition. Its middle else will start here. Is it not? Middle else will be executed. When middle else will get executed? When middle if is going to fail. Okay, you can make one comment. Before that, what is closed here? What is closed here? What is closed here? Middle if is closed. Middle is closed. Is it not? So that when middle else will get executed, so what about this else? It is the middle else. So when middle if is closed, immediately it should start with middle else. Middle else. Middle else. When it will get executed, it gets executed when middle if fails. Next, let us close outer if also. So what is happening here? Outer if is closed. Yes. Yeah, outer if is closed. Before that, opening outer else, first you have to close. So when some if condition is closed, immediately corresponding else condition will get started. That you please remember. See, when middle if is closed, middle else started. When inner if is closed, inner else started. Simple logic, is it not? So outer if is closed. Outer if, so that immediately outer else will get started. Is it not? So here is your outer else. Section of code will be executed. When this code will get executed, and what about this? Let us comment. It can be called as else. Statement can be called as outer else. When it is getting executed, it gets executed and outer fails. Because when outer if fails, immediately you have to look for outer else. Got it? When middle if fails, you have to look immediately for middle else. And during else, there will be no testing. Blindly, you can execute that. Okay. And this is about nested if. Any doubts in this? Please ask me. Let me know whether you are having any doubts in that. Okay. Right. And then let me move to switch case. Is the next one. So what do you mean by switch case? So they have given some diagrams also. You can understand. See this. Any doubt in this? Please ask me. Look at this, and if any doubt, please ask me. No, really? So if the condition is true, then what will happen? See where it is heading towards. If the condition is true, it is heading towards statement 1. If the condition is going to fail, it is heading towards, some bypass road is there. Can you see? You are bypassing statement 1. So if the condition is true, you should not bypass. Means, for example, you have entered Chennai. Roads are all open. So you can get into the city. This is city. Statement 1 is city. But you want to go to Madurai without going to Chennai. From Delhi you are going, or from Hyderabad you are going to Madurai. So you need not go to Chennai. You can bypass. Some outer ring road will be there. Na? You need not go into the city internally. You can take bypass like this and reach Madurai like this. Because your goal is not to reach Chennai, you have to reach Madurai for that matter. So if you want to reach Chennai, then don't go for bypass because your target is getting into the city. You have to go all the way and execute statement 1. And then once you go there, whatever statement is given after that, in failure state, it will be executed. Not only failure, but even after truth value of this also, it will be executed. Because for statement 2, there is no condition. Is there any condition for statement 2? Tell me. No. Only for statement 1, condition is there. If you have a close look, for you can execute statement 1 only when this condition is true. When the prevailing condition is true, then only statement 1 will be executed. Otherwise, bypass that, take the next statement. And if true, this condition, statement 1 will be executed. And after that, where to go? Go for statement 2 because no testing next time. They are not given any testing. Right. And what about this diagram? Did you understand this? How to interpret if else? If true, take right side and execute statement 1. If false, take left side and execute statement 2. After execution of either statement 1 or statement 2, because any one only you can execute in if else. After that, finally, your goal is common in both the cases, whether you get truth value or false value. Irrespective of that, statement 3, for sure it will be executed. Is it not? Yes, because see the direction. Only for statement 2, the condition should be false. Only for executing statement 1, the condition should be true. But for statement 3, either false or true, no issue. You will be heading towards that soon or later. I have given some examples, so you can try. Can you understand this? I am leaving to you. Please see this example. Any doubt, please ask me. What is happening? Can you say something about this program? Try to say. Execution starts from main function. Inside what is done? Can you say in your words? You can share among yourselves and talk about this program. Yes. Yes. What is happening internally? Yes, tell me. Enter two numbers. You are going to enter two values one for X, the other one for Y. And then what is done? Gone for testing the condition through if condition. So if I give 5 and 4 for XY, is it true or not? 5 for X, 4 for Y. Yeah. True means what will be done internally? The bigger number is 5. 5 because I have given 5 for X, right? If I have given 4, 5, then false means take else path, that will be executed. The bigger number is 5. Otherwise, here 3 numbers are taken. So how they have taken 3 numbers? Try to understand this. Enter 3 numbers. 1, 2, 3 I entered. We have done this before also. 1, 2, 3. Please remember. So if X is greater than Y, is it true? 1, 2, 3. I have given orderly. False. So don't get inside. Take else. L is equal to Y semicolon. What is L and what is Y? L is a temporary variable. What is there in Y? 2 is there. Because 1 is not qualified now. In the first if condition, 1 is failing. Combination is there between X and Y. Here you can see combination is there between only X and Y. And who succeeded? If I take 1, 2, 3, X or Y, Y is big. So the condition is false. So you have gone for else. Inside else, Y is equal to 2. Got it? Y is 2, none. I mean, L is equal to Y. Y means 2. So L will become 2. Large will become 2. So the latest, because first X is filtered here. It never went true. So X is away from computation here. If I give 1, 2, 3, X is out of computation or not. And then Y is, and then here Y and Z are tested because L is Y. L is equal to Y. Nothing but 2. L is 2. 2 is greater than Z. Z is 3, you know. Again, don't get inside if condition, go for else. The greatest number is Z. Z means 3. Yes, like that you can test. For example, if X is greater than Y is true, I have given 3 to 1. Then 3 is greater than 2. So inside X, what is there? What will be there? X. X means how much? 3. Yes. Don't go for else because this is true now. And then test the next if condition. L. What is L? Just now we have added 3. Here it is. L is equal to X na? 3. 3 is greater than Z. True or false? 3 is greater than 1. Z is 1. True. The greatest number is L, that is 3. Done. Like that, you can imagine this program. Understood, I think, right? Nested if statement. We have seen the syntax before. And see, they have given some flowchart. This is called as flowchart. These are all flowcharts which we are discussing with some diagrams. So, nested if statement. First, if first condition is true, then where to go? You are heading towards condition 2. If that is also true, execute this statement. Then come out. If condition 1 is false, take deviation. Go there. Is it not like this? If condition 2 is also false or condition 1 is false, then go there and because condition 1 is false means no chance for condition 2. Is it not? Outer condition, outer if this is. So if condition 1 is true, you can get inside and inner if can be executed. If inner if is also true, execute this. If inner if is failing, go out, come out. If outer if is failing, don't go to inner if, totally come out. Like that, they have designed that. And then if else. I do one thing. With this, I want to close today's class. I have taken my dinner and I had another class immediately. Anyways, tomorrow morning you are asking, na? We'll meet it right at 7. Okay. Shall I close for today? Okay. Yeah. Sunday, sure. Sunday we can have. Sunday I will be in Delhi, no problem. By evening I will be in some room and I will be teaching that. No problem. Sunday evening it is okay. I will reach by morning itself. Sunday morning flight I am going to Delhi. Sunday evening we will take it because I am sleepy also a bit actually. Some heavy work is there this month actually. That's why. Okay, thank you. Thank you. I have recorded this. I will send you recording as well. Okay. Please check later. Okay, thank you. Thank you.